Hello students, welcome once again for our chemistry lesson in year 10. My name is Mr. Situma. Today we are looking at the electrolysis of concentrated sodium chloride. Electrolysis of concentrated sodium chloride. Remember that we have been looking at the process of electrolysis. We have looked at the binary electrolytes, the decomposition of ionic compounds by use of an electric current. So today we now move on to the concentrated solutions. The objective of the lesson today is that at the end of it all, we should be in a position to state and explain the observations made when concentrated sodium chloride is electrolyzed using inert electrodes. When concentrated sodium chloride is electrolyzed using inert electrodes. Now, to start off, we need to do some few definitions. When we talk of a concentrated solution, we are referring to a solution which contains more of the solute than the solvent. This is a solution which has more of the solute than the solvent. When I talk of the solute, I'm implying the solid. And then when I talk about the solvent, I'm talking about the water. So this particular solution that we're referring to as a concentrated solution contains more of the solid compared to the water. For example, when you have a larger mass of an ionic compound dissolved in a little amount of water, not all the solid will actually dissolve. It's just a small amount of it is going to dissolve. That is what happens when you have a lot of ionic compound, a lot of ionic compound in solution. Now, this solid remains partially dissolved in water, and even if you heat this particular mixture to a specific temperature higher than the room temperature, the solid will still remain undissolved. That means the excess solid will remain undissolved. At that particular state, this solution is said to be a saturated solution. This is said to be a saturated solution. Now, in the electrolysis of sodium chloride, we prefer to use a saturated solution because we will have a larger number of the ions of the ionic compound. That means we will have a lot of the sodium ions, a lot of chlorine ions, and also the hydrogen and hydroxide ions. But in terms of the comparison, we'll have more of sodium and chlorine ions in the solution. Now, when you have very many ions in solution, it means there will be effective electrical conductivity. Remember, electrolysis is based on electrical conductivity. So if we do not have enough ions, and remember that the electrical conductivity in molten or aqueous solution is facilitated by the presence of mobile ions, then when the ions are in high concentration in solution, the electrical conductivity will be very effective. Now, when a concentrated solution of sodium chloride is electrolyzed using graphite electrodes, the products formed at the electrodes depend on the ions present. I want you to look at this, that we're looking at a concentrated solution of sodium chloride. Sometimes in chemistry, we refer to it as brine. We call it brine. Brine, B-R-I-N-E, B-R-I-N-E. So when you hear of brine, then we are talking about a concentrated solution of sodium chloride. So when you're doing this using graphite electrodes, and when you talk of graphite electrodes, these are the inert electrodes. Remember, the key aspect in this process is using the inert electrodes. Then the products will depend on the ions which are present. For example, in this electrolysis, the ions present in solution are sodium ions, we have chloride ions, we have hydrogen ions, and we also have hydroxide ions. So we have 4 ions, 4 major ions: sodium ions, chloride ions, hydrogen ions, and hydroxide ions. Now, in the discharge of the ions, you can be sure that there will be some of the ions which will not be discharged and some will be discharged. We looked at the factors which affect the discharge of the ions when we were looking at the binary electrolytes. We stated 3. 1 is the concentration of the ion in the electrolyte, 2 was the type of electrode, and then 3 was the location of the ion in the electrochemical series. The location of the ion in the electrochemical series. Now, the diagram that we have shows the number of the type of ions which are present. We have sodium ions, we have chloride ions, we have hydroxide ions, and we have the hydrogen ions. All of them in the electrolyte. But when you look at the two, we dissolved sodium chloride in water. So the ions which come from the sodium chloride as the ionic compound are the sodium ions and chloride ions. Sodium ions and chloride ions. These ones are from sodium chloride solid that we dissolved. Then hydrogen ions and hydroxide ions are the ones which are coming from water. Those are the ions that come from water. It's a simple set that describes or helps us to understand how these ions come about. The concentration of sodium ions and the chloride ions is higher than the concentration of hydrogen ions and hydroxide ions. If you still remember the statement of our discussion today, we say that it is the electrolysis of concentrated sodium chloride. So the term concentrated was attached to sodium chloride, and therefore the concentration of sodium ions and chloride ions is much higher in the concentration in the solution compared to the hydrogen ions and hydroxide ions. Now, because sodium ions, chloride ions, hydrogen ions, and hydroxide ions have different charges, the hydrogen ions and sodium ions, which are positively charged, are attracted to the cathode. These two are positively charged ions. They are attracted to the cathode. The two, therefore, form what we call the cations. Because sodium ions and the hydrogen ions are positively charged, then we refer to them as cations. So they are attracted to the cathode. The hydrogen ions are easily discharged because sodium ions are found above hydrogen ions in the electrochemical series. I'll still revisit the 3 factors that affect the selective discharge of the ions. One of them, which is being used in this case, is the location of the ion in the electrochemical series. So because of this, the hydrogen ions are easily discharged because the sodium ions are placed above hydrogen in the electrochemical series. So in the case of these two cations, when sodium ions, despite their higher concentration in solution, go to the same cathode with the hydrogen ions, the hydrogen ions will be discharged compared to the sodium ions. Let's investigate what happens at that, and then we shall also look at the anode in our next lesson. See you then.